A very good afternoon to all of you. Today we are going to discuss a very important phenomena, that is a signal, which is a very important concept of digital signal processing. As far as signal is concerned, it is a function of time, distance, position and pressure, or you can say a temperature, etc. And it represents some variable of interest associated with the system. So you see that a signal is nothing but it can be associated with a system, or we can say that without system a signal is nothing, because we are in a system, we are having number of variables: voltage, time, current, force, pressure. These are the electrical and mechanical systems, but we are having other systems also related to any other signal, right? So as far as the electrical system is concerned, in this we are having two types of signals: electric current and voltage. In electric current we are having IT, it is denoted by a signal IT. Then a voltage is there, it is denoted by a signal VT. Same as the mechanical system, in this we are having a force, a pressure and a torque, right? So this was a brief introduction of a signal. Later on we will be discussing the classification of the signal, that is a continuous time signal and a discrete time signal. As we can see that for continuous time signal, xt is there. For continuous time we are having xt, and for discrete time we are having xn. Here you can see a proper representation of a continuous time signal, right, because it is varying with the variable t, time, and here we are having samples of a signal. This continuous time signal is converted to its samples with the help of sampling process that we will deal it with later on. And now the very important phenomena of continuous time signal is that in this we can have fractional part as well as the integer part. I mean to say that in this we can have the values of time in points 1.1, 1.2, 1.3, 1.4 and so on, and also in integers 1, 2, 3, 4, 5, 6, right? But in discrete time system, discrete time signal, we are having only integer part, we are not having any fractional part. So integers like 1, 2, 3 up to infinity, we are not having any fractional part. Okay, so this was all about the signal, in a brief introduction of a signal and a classification of a signal, right? Now we will be discussing the representation of a discrete time signal. Representation of discrete time signal. Okay, so in this we can have a proper diagram, a proper sketch of discrete time signal, and from that signal we can implement many other signals also. Okay, so let's have an example. Let's have a question of a discrete time signal, that is we are having a signal of xn. Here we are having positive n, here we are having negative n, and here we are having xn. It's amplitude 1, amplitude 2. Amplitude can be in fractional part, okay, but the value of n cannot be in fractional part, it has to be in integer only. So according to the question we can mark the amplitudes. These dots indicates that -2, at -2 we are having 0, at -1 we are having 0, at 0 we are having 0, at 1 we are having 0, at 2 we are having 1, at 3 we are having again 1, at 4 we are having 2, and so on. So this is a proper what should I say, it's a proper sketch of discrete time signal. Now we can implement many more signals with the help of this signal. For example, if we want x of 2n, okay, so how will we represent this type of signal in a form of x of 2n? Here we are having n and here we will be having 2n. So let's see how we'll transform this particular signal in 2n. This will be x of 2n. Again the same points 0, 1, 2, 3, 4, 5 and 6. Minus 1, minus 2, minus 3, minus 4, minus 5, minus n. Okay. Now we'll be starting with 0. Okay. So at 0 we are having the amplitude 0 only. Okay. But now we have to deal with 2n, and these are the values of n. So we can write here, we can write 2n equal to 0. Starting from 0 value, starting from 0, we can place 2n equal to 0. So n will be equal to 0. तो जो वैल्यू पहले 0 पे रही होगी अब भी वही वैल्यू 0 पे होगी. Whatever value is at 0, the same value will now be at 0 only. It means it will remain 0. Okay. Then 1, 2n equal to 1. So n will be equal to 1 by 2. We cannot take this because this is a fractional part. Leave it. Okay, leave it. 2, 2n equal to 2. n will be equal to 1. Okay. तो जो वैल्यू पहले 2 पे रही होगी वही वैल्यू अब 1 पे आएगी. वट एवर बी द वैल्यू एट 2 सेम विल बी वैल्यू एट 1. तो 2 पे कौन सी वैल्यू थी? 2 पे थी 1, तो 1 पे कितनी आ जाएगी? 1 आ जाएगी अब. ओके. नाउ अगेन 3, so 2n equal to 3, n will be equal to 3 by 2. Cancel it, no need to take it because this is a fractional part. n equal 2n equal to 4, n will be equal to 2. So whatever be the value of 4 at 4, the same value will be at 2. So we were having 2 at 4. So 2